So the last section was about acute angles, those that measure less than 90 degrees. What about if it's a non-acute angle? So what if that angle is not acute? Well, how does that even happen? So you could have something like a triangle, and let's say that this angle is 20 degrees. Now here's the reason that I'm writing it on the X and Y axis. Now take that same picture, so take this and then flip it over into the second quadrant. So when you flip it over, it would look like this. So this is called a reference angle. So the original angle that would be given is starting from the x-axis, then measured this direction. That's the traditional way to measure angles when you have the xy system. And so then how much would the angle theta be? Well, since this is a straight line, 20 plus theta has to equal 180 degrees, which means that theta is equal to 160 degrees. And this is called the reference angle for 160. And the symbol for reference angle is theta with a hat. Theta hat equals 20 degrees. Okay, now what about if you take this picture and then you flip it down until it's in the third quadrant? So it would look like this. So now this little 20 degrees would be right here. So this would be the 20 degrees. Now the original angle, theta, you measure it from the x-axis. You may have heard me say this before. You measure this way. So that means up until right there, that's 180 degrees. But you need to keep going till the terminal side. So the theta would be 180 plus 20 more. That's 200 degrees. And then this little theta would be the reference angle. So it's actually called theta hat since it's the reference angle. Then one more possibility. Now take this triangle and then flip it over here. So between the x-axis and this line, it will be moved over here. It'll look like this. So this is now the 20 degrees. So the original angle, you measure it from the positive x-axis and you go this direction, which means we have to go almost all the way around a whole circle. If we went all the way around, that would be 360. That means we're missing 20 degrees, so that means the original angle theta would be 340 degrees. So for a given angle of 340 degrees, then the reference angle is equal to the 20 degrees. So that's the first part that we need to do in order to deal with non-acute angles. Like this angle 160 would be given, that's not an acute angle. And then you would draw that first, and then you'd have to find this missing part between the black line right there and the x-axis. So remember, the reference angle always goes from the side of the triangle or the terminal side of the angle to the x-axis, to the x-axis, to the x-axis, to the x-axis. So for example number 1, find the reference angles, part A. Suppose that theta is equal to, how about 200 degrees? Oh, wait, I just did that one. Okay, how about 1200 degrees? Okay, let's see. 1200 degrees. That would mean go around the circle once. That's 360 degrees. And because this is such a big angle, instead of me just going around the same circle and then you can't tell how many times I went around, then I just make the next loop a little bit wider. So I've got 1200 degrees. I've gone around the circle once, so that takes care of 360. Now go around the circle a second time. We get to subtract off another 360. Now go around the circle another time. We get to subtract off another 360. And now go 120 degrees. So as far as going around the circle several times, I've done that. I'm now down to 120 degrees. So now I'm going to redraw it because the red squirrel, like a mod pizza, yeah, that is going to be too confusing. So I'm going to move over and say now go 120 degrees. So this would be 90 degrees. This would be 180. So 120 would be about like this. So this is now the 120 degrees. And this will be the reference angle. So if this is 120, and down here, it has to be a total of 180, that means that this is 60 degrees. All right, now I want a way of testing to see if I got this right. So I'll pick a trig function, sine of 1200 equals that thing. And sine of 60 equals the exact same thing. So I'm pretty sure that I got it right. Okay, that was number 1, part A. And then what about part B? How about if the angle equals negative 110 degrees? Then what's the reference angle? So when it's a positive number, you start here and then start going up to draw the angle. When it's negative, you need to go down. Now when I get to right here, that would be 90 degrees, and then 100, and then 110. So it would actually be over here, would be the terminal side of the angle. And so that means going from here to here, that's negative 110 degrees. And then the reference angle would be whatever is between the terminal side and the x-axis. So never measure it to the y-axis, always to the x-axis. And when you find out what the reference angle is, you just call it positive. You're just measuring what's the size of this angle. The negative meant this went in the downward direction, but it's still a measure of 110 degrees. So the reference angle would be, so all the way around to here would be 180. So this would be 180 minus the red part. And that equals 70 degrees. So I want to test my answer. So I'll pick a trig function, tangent of negative 110 equals that decimal, and tangent of 70 equals the exact same thing. So now I feel confident that I got this right. Okay, then to use this. So for example number 2, find the exact value, which is a good hint that we're probably going to be using one of these two triangles. So some people use the unit circle and memorize the unit circle, which I feel you really don't need to do, because if you just know these two triangles and this little symbol, a smart trig class, that right there replaces the whole unit circle. Anything you could do on the unit circle, you could do with these three little objects right here. So if it says use the unit circle, then you could just use these guys. Okay, find the exact value. How much is, so part A, how much is cosine of 225 degrees? So first of all, draw that angle, 225 degrees. So over here would be 180, over here would be 270. So 225 is somewhere in between like this. So going from here over to here, that is 225 degrees. Now, like I was just demonstrating, a glare, sorry. When you have the angle and you have the reference angle, the answers are going to be the same. So there is the angle, there is the reference angle, the answers are the same. Now it could be that one turns out to be positive and one turns out to be negative. So that's the reason we would need this part right here to figure out, is the answer supposed to be positive or negative? Okay, but first find the reference angle. Well, this up to right there is going to be 180. And if you take 225 and then subtract 180, that will give you the reference angle. So that is 45 degrees. So I could draw the triangle right here. And then for me, it's sort of upside down. I would rather draw it like this. So this could be the right angle right there. And then this is 45 degrees, which actually means this has to be 45 degrees, which means the sides are 1, 1, and the square root of 2. So how much is cosine of 45 degrees? Cosine would be adjacent over hypotenuse. So it'll be 1 over the square root of 2. Now the answer for cosine of 225 degrees will equal the same fraction, but this one might be negative or might be positive. That's where we use a smart trig class. Tells you when they are positive. This is in quadrant 3. That means tangent is positive, cosine should equal a negative. So the answer should be negative 1 over the square root of 2. That's my exact answer. And I just want to double check. So let's see, I got negative 1 divided by the square root of 2. That gives me that decimal, negative 0.707. And then find cosine of 225. And it equals the exact same thing with the negative and everything. So this one is finished. Now for part B. As soon as I get a piece of paper, part B. So this is still continuing example number 2, find the exact value, but part B. How much is sine of negative 690 degrees? So negative, that means going the opposite direction. And we're going to need to do that several times. So go this direction, and when you go around once, that's 360. So $690 subtract 360, it leaves 330. So I still need to go around 330 degrees, and we're still going in the opposite direction. So if you go another 330, that is almost all the way around the circle till right about here. But I'm going to draw it in another picture. So we were right here, and then continue around. So we would go like this, continue around until right about there. So from here, continue around, and when I subtracted them, I got 330. So stop right here, and this is negative 330 degrees. And this will be the reference angle. And since all the way around a circle is 360, and then this takes up 330 of it, this must be 30 degrees. So that means I'm going to be using a 30, 60, 90 triangle. Here's 30, 60, and 90. Across from 30 is 1. Across from 90 is 2. And across from 60 is the square root of 3. How much is sine? So sine of 30 degrees, sine is opposite over hypotenuse. All right? Then sine for negative 690 degrees has to equal the same fraction. A smart trig class, this is where they are positive. And this angle ended up being in quadrant 1, and all of the trig functions are positive in quadrant 1. So that means that this is my answer. Vamos a ver. How much is sine of negative 690? It equals a 1/2, and it's positive. I got it right. Okay, that's it for this section. Talk to you again soon.